Dear students, today we will be discussing the conformation of three acid radicals, that is nitrate, acetate and oxalate. This is in continuation to my previous lecture in which we discussed the conformation of chloride, bromide and iodide. I hope in these two pieces you will be able to comprehend the conformation of acid radicals which are indicated or detected with concentrated H2SO4 test. So let's begin with the today's discussion. Nitrate. The indication for the presence of nitrate is obtained in concentrated H2SO4 test as a preliminary test. We get the evolution of reddish brown NO2 gas. I told earlier also that if you get NO2 gas with dilute H2SO4, then it would be out of nitrite. However, if you don't get NO2 gas, reddish brown gas with dilute H2SO4, but get only on heating with concentrated H2SO4, it indicates the presence of nitrate. Then we perform the following tests as confirmatory tests. So the first test for this is copper turnings test. If you remember, while discussing the preliminary tests for these radicals or nitrate, I discussed with you that we take salt and heat with the concentrated H2SO4. We may get slight reddish brown gas, then we add a paper pellet, and on the addition of paper pellet, dense white fumes of NO2 gas come out. The same sort of principle is used here. You see what happens, that when we heat the given nitrate with the concentrated H2SO4, then we get the formation of nitric acid. That nitric acid has to be decomposed. So then either paper pellet or copper turnings will help it. And then nitric acid will be decomposed readily and nitrogen dioxide gas is evolved, which will give you reddish brown color. But here, what is the chemistry behind? Let us say we have got, say, magnesium nitrate with us. We heat this with concentrated H2SO4. We get the formation of magnesium sulfate plus 2HNO3. Now this HNO3, we are doing while hot, that we are heating it. It decomposes to give you water plus 2NO2 plus decent oxygen. Now copper turnings will combine with this to give you copper oxide CuO. Now this CuO will again react with nitric acid to give you CuNO3 twice plus of course water. So in a way, if you add these two, then we can, instead of this, we can write this equation that copper plus 4HNO3, 2 here and take 2 here. So this is copper plus 2HNO3, that will give you copper nitrate. Plus of course we get 2NO2 plus water, etc. So in this case, had copper not been there, then this nascent oxygen would not have been used. As we discussed earlier also, if there is no oxidizable material, then we get nitrogen dioxide and O2 gas is produced. If we take 4 of this, then this will become 2 water, 4 NO2 and NO2 will be evolved. However, when copper turnings are there or say paper pellet is there, then this nascent oxygen is used up and this reaction is moved in the forward direction with the more intensity and more NO2 gas is evolved, which gives you reddish brown color. So test is that while heating with copper turnings and concentrated H2SO4, a nitrate gives dense reddish brown fumes of nitrogen dioxide. Now, second test for this is the ring test. So what this ring test is? In this we take salt solution in water, because all nitrates are soluble in water. So in that nitrate solution we add freshly prepared ferrous sulfate solution, and then we add concentrated H2SO4 along the inner wall of the test tube in such a way that it should not directly pour into the solution. Sulfuric acid, is heavier, then it will just go and it will make a layer at the bottom of the test tube. At the junction of the two liquids, that's the H2SO4 and the nitrate plus ferrous sulfate, what happens? We have got, let us say we have got nitrate, say magnesium nitrate. It combines with sulfuric acid to give you magnesium sulfate plus HNO3. Now this HNO3 decomposes to give you water plus 2NO plus 3 nascent oxygens. Now you might think that sometimes we decompose nitric acid and we write here NO2, and sometimes we write here NO. You see what happens whenever nitric acid is formed in hot conditions. That is, we are heating the nitrate with say HNO, the sulfuric acid. Then under those hot conditions we get the nitric acid, and under those conditions nitric acid decomposes to give us nitrogen dioxide. However, in the present case, we are generating nitric acid in cold solution, and in that case the nitric acid dilute state, that is, in dilute solution nitric acid decomposes to give you NO. Now, what's the role of ferrous sulfate? Ferrous sulfate plays a dual role. Ferrous sulfate consumes nascent oxygen in the presence of that sulfuric acid to give you ferric sulfate. Now, this reaction will consume this nascent oxygen, and this reaction will be moved in the forward direction. And as a byproduct of this reaction, we will be getting this NO, that is nitric oxide. Then this ferrous sulfate, remaining ferrous sulfate, will combine with NO in the presence of water to give you FeSO4NO. We wrote this equation earlier also, that this is a nitroso-ferrous sulfate. Nitroso-ferrous sulfate. And in my earlier lecture I told that actually it is water molecules are also incorporated. This is penta-aqua nitroso iron 2 sulfate. So this is dark brown. And you see, all this is happening at the junction of the two liquids. At the junction of the two liquids, this compound is formed, and that forms a dark ring. If we shake the test tube, then the solution mixes and the whole of the solution turns reddish brown. So this is known as ring test. Acetate. Indication for acetate is obtained with the help of concentrated H2SO4 preliminary test, because in that case, when we heat the salt with the concentrated H2SO4, then the outgoing vapors are of acetic acid and they smell like that of vinegar. While performing confirmatory test, first test we perform is, that is, number one is ester test. Ester test. In this test, what we do is, we take the salt, then we add say half a milliliter of concentrated SO4 and a milliliter of ethyl alcohol, then we heat it strongly. What happens? Suppose we have got sodium acetate in the presence of sulfuric acid, we get the formation of acetic acid plus Na2SO4. And this acetic acid will combine with ethyl alcohol. We'll get CH₃COO C2H5 plus of course water. This is ethyl acetate. This is ethyl group, this is acetate, and this ethyl acetate has got sweet fruity odor. Sweet fruity odor. So this is first test, that is ester test. Another test in this case is ferric chloride test. FeCl3 test. To the salt solution in water, we add a neutral ferric chloride. That is, say, we have got this sodium acetate, plus we have got ferric chloride. We take 3 of this, and we get the formation of CH₃COO thrice, then Fe. This is ferric acetate, and this has got deep brown color. Now I used here a word neutral ferric chloride. What is neutral ferric chloride? You know, ferric chloride is an acidic salt. When you dissolve ferric chloride in water, then the solution is acidic due to the liberation of a little of H ions, because acidic salts when dissolved in water turn the solution acidic. Basic salts when dissolved in water turns solution basic. So in this case, we take ferric chloride solution, then we add drop wise very dilute ammonia solution. When we add ammonia solution to it, then you see what happens, we'll get the formation of ferric hydroxide, but still acid is there, it will disappear. So we shake it, and after that we heat the solution. When the solution becomes clear, then it is neutral ferric chloride. Now this ferric chloride, when you heat this ferric acetate with water, hydrolysis takes place, and you get the formation of CH₃COO OH twice, then ferric. This is basic iron acetate, plus of course we'll be getting 2 CH₃COOH. So when this reddish brown solution of ferric acetate is heated with water, boiled with water, then we get the formation of brownish precipitate of basic iron acetate. So in this case, when this is heated in water, then we get the formation of this basic iron acetate, and this is a brown precipitate. So the next test is of oxalate. Now indication for oxalate is obtained in concentrated SO4 test. That is, when we get the evolution of carbon dioxide gas with concentrated SO4 test, then it indicates oxalate. Then tests for oxalate are: number 1, we have calcium chloride test. What we do is we take water extract, salt solution or soda extract whatsoever, because there are so many oxalate which is not soluble in water. So we perform with the soda extract. So let us take the case of, say, we have got soda extract, and it is sodium oxalate, Na2C2O4, soda extract. Then this soda extract is acidified with acetic acid. We heat the solution so that the undecomposed carbonates are eliminated, boiled off, and then we add calcium chloride solution in water. What we get is, we get the formation of calcium oxalate, CaC2O4, which is a white precipitate, plus of course we will be getting 2NaCl. So this was calcium chloride test. Another test is KMnO4 test. You know, this KMnO4 test is almost the same test which we do while performing KMnO4 titrations with oxalate. So what this test is? We take the salt solution, we add a few drops of KMnO4 followed by the addition of a few drops of H2SO4, maybe dilute, maybe concentrated, and then we warm the solution. After some time, if the color of KMnO4 is discharged, it means oxalate is there. So how it happens? Suppose we have got this sodium oxalate in your soda extract. When we treat this with H2SO4, we get the formation of CH₃COO plus of course sodium sulfate. Now you know this oxalic acid or oxalate ion is a reducing agent or oxidizable material, and acidified KMnO4 is an oxidizing agent. So we get this KMnO4 plus H2SO4 gives you K2SO4 plus MnSO4 plus water plus nascent oxygen. And when this nascent oxygen attacks oxalate and oxalic acid at say 60 to 70 degrees Celsius, then we get the formation of water plus 2 carbon dioxides. And during this process, since this nascent oxygen is being consumed here, this reaction moves in the forward direction, and this purple colored KMnO4 changes into almost colorless solution of these compounds. So, well, students, today we discussed the confirmatory tests for the acid radicals, which we identified, which we detected with the help of concentrated H2SO4 test, that is chloride, bromide, iodide, nitrate, acetate and oxalate. So with this, we finish one section, that is the confirmation of common acid radicals. First of all, indication with the dilute H2SO4 test, KMnO4 test and concentrated H2SO4 test, and then confirmatory tests of these radicals. So I hope this sequence of lectures would definitely give you an insight regarding the analysis involved in of acid radicals in the salt analysis, and in the subsequent lectures we will be discussing with the topics of basic radicals and so on. So thank you very much for today. Thanks.